Trigonometry. And when do I use the cosine law versus the sine law? Well, first thing we need to remember to do this is what is the sine law and what is the cosine law and when can we use them? Remember, for the sine law, it's sine A over side A, sine of angle B over side B, which is also equal to sine of angle C over side C. And you can use it when you know two sides and the angle opposite one of the given sides, or one side in any two angles. The key is we need to know a complete ratio in the proportion and one other piece of information. For the cosine law, we can write it as a squared is b squared plus c squared minus 2bc cos A. We could rearrange it with other letters, but since we can name our triangle sides whatever we want, the key we have to remember here when we're doing this is that the side that's on the left side of the equal sign must be opposite the angle used on the right side of the equation. And you use the cosine law when you have two sides and the angle in between the two known sides, which is called a contained angle. Or if you know all three side lengths, then you can solve for a missing angle. Now we're going to do some problem solving. And we need to remember there are several things we can use to solve triangles. And I think that should just say solve triangles, not right triangles. Sorry about that, guys. The angle sum of a triangle theorem is very useful. Pythagorean theorem. Right angle trigonometry using the primary trig ratios, or we can use the word SOHCAHTOA to help us remember that. Sine law and cosine law. What we're going to do is work on some equations. We're going to set them up, including let statements to introduce the variables. We're going to include fully labeled diagrams, and we're going to analyze the strategies we can use to solve the problem and explain why they do apply and why others do not. And we're going to create a complete equation using the correct strategy to solve the problem. We are not going to actually solve them necessarily. Depends on how much time we have. So if we look at this question, it says two boats leave Whitby Harbor at the same time. Well, that's important. There's two of them. One boat's heading 19 kilometers to its destination in Lake Ontario. And the second boat is on a course of 70 degrees from the first boat. And it travels 11 kilometers to its destination. How far apart to the nearest kilometer are they when they reach their destination? So really, what am I looking for? How far apart they are, and that's going to be measured in kilometers. So if I think about it, the first thing I need to do, it said use let statements, but before I can do that, I need to draw a diagram. So I've got boat A. This is the harbor right here. And boat A goes up here, and he travels 19 kilometers. Boat B makes an angle of 70 degrees with boat A when it leaves, and it travels 11 kilometers. We want to know the distance in between them, so we'll call that D. So we can say let D represent the distance in between the boats when they reach their destination in kilometers. And there's a proper sentence written on the next page, and for the sake of time, I'm not going to have you write this out. Now, if I take a look at my graph, we talked before about the fact that we need a complete pair to use the sine law. I don't see a complete pair anywhere. I can't find either of the other missing angles to create it, so it's definitely not a sine law question. I'm going to go back to the next slide because I made a mess of that diagram, and we're going to have a look again. So what do I have? I have one missing side, and it's opposite the angle I know. Well, and I know the other two sides. That seems to me that it's a classic cosine law question. I can't use angle sum of a triangle theorem because I'm looking for a distance, and I can't use it to find the other angles, not yet. I can't use SOHCAHTOA because it's not a right triangle. And I can't use Pythagorean theorem because it's also not a right triangle. So we're going to work on cosine law and how we can make it work. So if I go back here, I'm going to just look at my equation. D is the side that's all alone. 11 squared plus 19 squared minus 2 times 11 times 19 times the cos of 70 degrees. And if you want a number crunch in your calculators and solve it, great. Give practice. Otherwise, you can move on. But if you're going to solve it, don't forget you need to square root D at the end in order to find the distance. Next problem. The length of equal sides in an isosceles triangle is 54.4 meters. The angle at the ends of the equal sides is 74 degrees. The angle opposite the base is 32. Determine the length of the base of the triangle. So I want the length of the base, and its units will be in meters. Again, before I introduce any variables, I'm going to draw myself a picture because a picture is worth 1,000 words. I've got an isosceles triangle. I've got two equal sides. It tells me their lengths are 54.4 meters. It tells me the angles at the ends of the equal sides are 74 degrees, so I can put that in. And the angle opposite the base is 32 degrees. Find the length of the base. So I'm going to put that there. I'm going to say let x represent the length of the base. The angle sum of a triangle theorem doesn't make any sense in this context because I already know all three angles. I'm not going to use it. I'm going to eliminate the primary trig ratios and the Pythagorean theorem because there is no right angle. That leaves me cosine law and sine law. Cosine law I use when I have two sides and the angle in between them. So I could use cosine law to solve this. Or does sine law work? Do I know a complete ratio? I do. And which one's going to require less calculations and less number crunching? I would say the sine law is going to. So I would do sine of 74 over 54.4. And I'm going to set that equal to the ratio that has x in it. So sine 32 over x. And of course, that's much neater in the next two slides here for you to read. And your answers down there at the bottom. And before class tomorrow, please do exercise 6, page 13, number 1 and 2.